Hi, everyone. Welcome and thank you for attending this month's webinar presented by Dr. Antonia Califat. Her presentation is entitled Biomonitoring for Public Health Action, Challenges and Opportunities. My name is Nicole Tolby and I'm chair of the membership committee for the International Society for Exposure Science, and I will be moderating this webinar. For those of you who are not ISES members, please consider joining the Society as we offer many benefits, including exclusive access to this recorded webinar and the presentation after today's live session. Please visit the ISES website for more information on member benefits. So I've got a few quick housekeeping notes before I turn the presentation over to Dr. Califat. So in the upper right-hand corner of your computer screen, you'll see your control panel. Please note that the webinar is in listen-only mode for all participants. So throughout the presentation, you can type a question in the question box or in the chat box, and we will answer questions at the end of the presentation. So at this moment, I'd like to introduce Dr. Antonia Califat. She is the chief of the Organic Analytical Toxicology branch at the Centers for Disease Control and Prevention in Atlanta, Georgia. She leads CDC's biomonitoring program for assessing human exposure to organic chemicals, such as pesticides, flame retardants, consumer product active ingredients, phthalates, and many others. She has developed and maintained extensive collaborative research with leading scientists in the fields of exposure science, epidemiology, toxicology, and health assessment, and has published over 460 peer-reviewed articles. She has been active in ISES throughout her career and served as a government counselor and a secretary. And with that, I turn the presentation over to Antonia. Thank you.
Hello, can you hear me?
Yes.
Yes. So this is Antonia, and I want to start by just thanking the webinar committee and Nicole for inviting me and giving me the opportunity of presenting the work that we have been doing at CDC for a few years. So without further ado, I'm going to be talking today about biomonitoring and what it can do for public health action. We live in a chemical world. We are surrounded by thousands of chemicals in the food we eat, in the products we use, the air we breathe, the water we drink. And therefore, there's no surprise that we are exposed to all these chemicals. And we are concerned about exposures because some of these chemicals are endocrine disruptors. Some of them are carcinogens. And for many of them, we actually do not have a clear idea as to whether they may be harmful to health. Chemicals do not obey biogeographical borders. And even if they did, with the world we have now and the world we live now of globalizations where, a chemical may be manufactured in one country, may be incorporated in one product in another and used in another one, then they certainly do not obey by any borders, or the borders are certainly very fluid. And because more and more recently, people have become much more aware of these chemical exposures, perhaps because of the large influx of social media and worldwide networking that we have seen explosion, I would say, in the last few years. And as a result, people, again, are much more aware of their environment, of the potential exposures coming from the environment, and many times are requesting fast interventions and regulations from the government. Did it go down? No. Working at CDC, Public Health Agency with a strong mission in prevention, one of our goals is to improve the detection, diagnosis, treatment, or prevention of disease, injury, and harmful exposures, including, yes, chemical exposures. And we are using biomonitoring, which is the technique that consists in measuring chemicals in body fluids to inform exposure assessment and to make sure that we actually are measuring what got into the body and to improve the exposure assessment. If you are in the biomonitoring business, you already know that is a technique that is seeing an increased acceptance, and then is widely used more and more often now than it was before. Just by looking at a PubMed search, looking for human and biomonitoring, it was very clear that we went for like fewer than 1,000 articles in 1995, and 25 years later, the number of articles have more than quadrupled. And this is because they have been, and they keep on being actually constantly, analytical chemistry advances. We are able now to measure more chemicals at smaller amounts and in a smaller amount of sample than we were before. There have been also much more widespread use of isotope dilution mass spectrometry, which is the technique that we use at CDC, and much more use also of robotics, which allow us to measure, analyze a larger number of samples with better precision and accuracy than we were before. Biomonitor has many public health applications, but today I'm really going to be talking about two major ones. The use of biomonitoring in large-scale surveys, primarily in NHANES, the National Health and Nutrition Examination Survey. This is a survey conducted by CDC on an annual basis, and that has been incorporating biomonitoring chemicals or biomonitoring since 1975, but really as we know it since 1999-2000. There are as well other national biomonitoring efforts, including the Canadian Health Measures Survey, the Korean National Environmental Health Survey, the German Environmental Survey, and HBM4EU, which is large initiative of about 30 European countries that want to promote the evidence for chemical policy making using biomonitoring. I won't be talking about those, but I just wanted you to know that it's not only NHANES. There are some other very important national biomonitoring strategies. And biomonitoring has also been used and more often now than before in epidemiological studies for improving the exposure assessment, including in studies of susceptible and vulnerable populations, as well in populations of those highly exposed, including people who may have been exposed accidentally through, for example, like one example was the C8 study with contamination of Ohio River water with PFOA, or, as a result of an accident like the dioxin exposure as a result of the Seveso incident back in 1976. And also studies in occupational settings that, for the most part, have higher exposures than those we are experiencing in the general population. Back in 2007, Larry Needham conceived like biomonitoring or the biomonitoring wheel, with biomonitoring at the hub of the wheel and the various uses of biomonitoring on the spokes of the wheel, and realizing and acknowledging that those spokes could be many more, and they could be, like just changing with time. I will be spending time today just talking mainly about those spokes, if you want, that are related to exposure assessment. But there are also some important ones in terms of epidemiology and that are looking at health effects. So I'll be giving you some examples on biomonitoring for setting reference ranges and tracking some trends. For helping with identification of some emerging chemicals, although in truth, many times when we look at them, they have already emerged. Not very often, but at least for general surveys for source identification, but in some cases, this can be used as well, and to monitor interventions. So one important use of biomonitoring is for setting reference ranges. And this is an example that relates to exposure to PFASs, poly and perfluoroalkyl substances. These are chemicals persistent in the body and in the environment that have been used extensively in commerce since the 1950s. But interest has raised and increased lately after EPA in 2016 promulgated or their health advisory, and the discovery that millions of Americans were drinking water that had levels of two of these PFASs, PFOA and PFOS, that were higher than the health advisory. We have been measuring PFASs in the U.S. general population of NHANES since 1999-2000. Even before these chemicals, the major manufacturer of PFAS discontinued production of some of them in the year 2000, between 2000 and 2002. But when we measured these chemicals, we were measuring them in adolescents and adults. So children 12 to 19 and 20 and adults 20 and above. It was realized a few years ago that we did not have a reference range for young children. And recognizing this, this deficiency, if you want, then we went on and then developed and analyzed, procured, I should say first, some serum that we could use to analyze for these chemicals. And we measure several of these PFASs in this slide. I'm only showing the four major PFASs, the ones that have been most studied to date: PFOS, PFOA, PFHS, and PFNA, in different populations of children. And the one, let me see if I can make this thing to work. And the ones that are highlighted are those in blue, and with the blue circle are those that are coming from NHANES. Of interest, these were NHANES data from 2013-14, and even though many of the children were born almost a decade after the discontinued production of some of these chemicals in the United States, we were still detecting them in their bodies, perhaps likely because there is transplacental transfer of these chemicals as well as exposure through breast milk or nursing. One very important use of biomonitoring, and particularly for national surveys, is tracking temporal trends. Polybrominated diphenyl ethers have been used as additive flame retardants in many consumer products, including some products used in electronics, as well as polyurethane foam in carpeting. However, because these chemicals are endocrine disruptors, they were changes in their manufacturing. Specifically in 2003, the penta-nocta BDE formulations were discontinued. And in 2013, the same happened with the deca BDE. Normally, we look at trends looking at individual samples, but in this particular case, what we did, we made pools. We used the NHANES samples to make pools. We pulled samples based on age group, on race, ethnicity, and on sex. And we did that for cost reasons, among others. But what was very interesting, and is what I'm showing on this slide, is that displays the concentrations of BDE47, one of these congeners. On the y-axis, we have the adjusted geometric mean on a lipid corrected basis. And on the x-axis, the different NHANES cycles. And it's very clear that based on these are the data by age group, that you're seeing that concentrations are, the trend is clearly going down between 5 and 20% since 2005. Again, suggesting that when there are interventions that remove chemicals from the market, exposures tend to follow those trends. They also go down. In some cases, this biomonitoring can also not only show you that there are trends in exposure, but then that they may be suggesting some what are the replacement chemicals. And this is an example drawn from phthalates. Phthalates are plasticizers used very extensively in many products, including, like in plastics as well as cosmetics. Because of legislative actions as well as public awareness, there have been many changes and uses in phthalates, and with the appearance of what we would call chemical alternatives. In this slide, we see two examples of two phthalates. In purple is DHP, diethyl hexylphthalate. In blue is diisononyl phthalate. And on the slide, what I'm presenting are different enhanced cycles and the concentrations. These are the geometric mean concentrations of the major metabolite of each one of these phthalates. And as you can see clearly, the concentrations of DHP appear to be going down, while the concentrations of DINP appear to be going up. I should say that in 2007-2008, the Consumer Product Safety Commission had an initial determination just banning certain phthalates, including DHP, from children articles. And then this regulation was permanent or became permanent in 2014. So it is possible that the use of DHP has been going down, while the use of alternatives such as another phthalate, DINP, had been going up. But then we go to 2015 and we see that the concentrations, even of the alternative, were going down. We think that this is due to the fact that replacing DHP is not only DINP, but perhaps many other alternatives, including DINCH, which is not a phthalate, but is another plasticizer introduced in the market in the year about 2002 for specific products. And it may have been, like concentrations that we are observing in ENHANCE. And I should say that these concentrations are not geometric mean, but the 95th percentile, these concentrations appear to be just going up. So it's very possible that DHP is being replaced by a myriad of different plasticizers in the market. As I said before, we like to think that biomonitoring is useful to identify emerging chemicals, although in truth, many times when we're looking at them, at least in depth in ENHANCE, is after they have already emerged. As any other type of chemicals, with pesticides, there's also a continuous evolution. We move from chlorinated insecticides or organochlorine insecticides to organophosphate insecticides to pyrethroid insecticides, and now more recently to the neonicotinoid insecticides, being imidacloprid one of the most widely used. Until the data that we showed last year, in which we demonstrated that about 50% of the US general population had been recently exposed to some of these neonicotinoid insecticides, we actually had no idea about the extent of the exposure to these chemicals. We measured 4 parent compounds and 2 metabolites. And also from this slide, what you can clearly see is that we detected much more frequently, and I should say also at much higher concentrations, the metabolites than the parent compounds. We detected acetamiprid only in 0.3% of the population versus N-desmethylacetamiprid in about 35%, suggesting also that most likely the metabolites are a much better biomarker of exposure to these insecticides than the parent compound, at least for general population exposures. Perhaps this is different under an occupational exposure setting. And I said that for a source that biomonitoring may not be very useful for source identification, and certainly not unless you have some additional information, for example, some type of questionnaire data. And this actually is what we had back in 2004. In a case study looking at exposure to phthalates for a study in collaboration with Russ Hauser at Harvard, looking at exposure to phthalates and semen quality, we came across a sample that had concentrations of a metabolite of dibutyl phthalate, which is a testicular toxicant, one of the most toxic phthalates in animal studies, that was considerably higher than the levels that we were finding in ENHANCE, even close to some of the levels that would have been looked at in toxicological studies. Upon looking at and confirming that the results were true, that there was no analytical error, it turns out that this was a man who was taking some medications for colitis, actually was taking 12 pills a day of a particular medication that happened to have dibutyl phthalate in the coating of the medication or the capsule. So the phthalate was helping the medication go through the acidic environment in the stomach until, just not releasing the medication until getting to the colon. Later on, we actually used enhanced data to confirm those case report findings. So we looked at data from enhanced from 1999 to 2004. And in enhanced, in addition to collecting the samples and undergoing a medical examination, participants also give a listing of all the medications that they take. Although enhanced staff removes the name, the trade name of the medication, they keep the active ingredient of the medication. So we found that there were 6 users of mesalamine, this is the name of the active ingredient, and almost 7,900 non-users. The graph speaks for itself, but what you can see clearly is among these 6 users, the concentrations of monobutyl phthalate were way, way higher, orders of magnitude higher than the concentrations of the non-users. Of interest, one of these users in enhanced was a pregnant woman. And what was very reassuring from a public health standpoint was that in the medication, the insert of the medication that contains phthalate, we observed that the manufacturers had actually indicated that this medication contains dibutyl phthalate and may cause fetal harm. Biomonitoring can also be used to look for the success or the lack of success of interventions. And this is one example that deals with the exposure to pHs from the use of indoor open pit stoves. Believe it or not, worldwide, there are about 3 billion people who burn biomass fuels in indoor open pit stoves. What is more troubling is that those who are more exposed to the pHs, or the air that in this indoor air, are women and children who are the ones who spend the longest amount of time inside the house. So it's of course of interest to find some alternatives that would provide the needed, like fuel for warmth and for cooking, while just decreasing as much as possible the exposure to potentially harmful pollutants. And we conducted a study years ago looking at open pit stoves and the stoves equipped with a chimney just to some exhaust to just take some of the air out in Peru. And we measured pH metabolites in the urine of pregnant women before and after the intervention. And what we observed was that depending on the biomarker, concentrations of these biomarkers had decreased by 20 to 40%, which is actually something pretty good if one can just stick with using those stoves with a chimney. Of note, however, is that even after the intervention, the levels in these pregnant women were higher than levels of pHs in U.S. smokers, as smoking is also a source of pHs. And actually, the levels in some of these women were comparable to occupational exposure. So there's still a long way to go. So biomonitoring has been used to at least just evaluate the success of certain public health actions, including the prevention of lead exposure, the prevention of lead. Am I still online? Hope I am. Yeah. So the prevention of the smoking bans, looking at the smoking bans in public places, which now is certainly has been one of the success stories, decreasing the exposure to environmental tobacco smoke among non-smokers. However, now smoking is being shifting from public places to private places, and as a result, then we're just seeing that the decrease in exposure to environmental tobacco smoke is not as high in children as it is in adults. most likely because children they cannot choose where to go. They're kind of stuck, and then if their parents are smoking at home, then they'll be exposed to the environment, to the smoke. The success of the restricting use of some phthalates in children's toys, and the removal of chemicals from the market. Now you go to Target or you go to the supermarket and you see, like compound is BPA free, paraben free. We actually don't know exactly what other chemicals replace those, but at least there had been some movement into removing certain chemicals from products. But at the same time, biomonitoring has certain important scientific challenges, including those that require like the best selection of the matrix and the biomarker, and this has to do with evaluating the exposure of interest. As I said before, in some cases, like when I was talking about the neonicotinoids, if we want to look at exposure to these chemicals, and background exposures, background level exposure, then most likely we actually probably need to look at the metabolites rather than looking at the parent compounds, because with the metabolites are the ones that are going to give us the highest sensitivity. However, if we were looking at exposures, at occupational exposures, perhaps the parent compound would be useful. Biomonitoring, however, doesn't only start in the lab. Biomonitoring is the success of a biomonitoring strategy starts from the very beginning with the collection of the specimens. It's very important that the collection and all the processes in between, all the pre-analytical processes, are conducted in a way that preserve the specimen integrity. Otherwise, you may have the best and the most precise measurements on a compromised specimen that would provide the wrong information. It's also very important to look at the timing of the exposure and the health outcome and see whether the biomarker of choice is able to link exposure and health outcome at least in a meaningful manner. And we are constantly trying to look for what are the next chemicals. And it's, as I said, most of the time, when we catch a chemical that has already emerged, is very difficult to kind of foresee what's going to happen in the future. With more and more, laboratories conducting biomonitoring, there is an important push for some type of harmonization, being in the way the analyses are being conducted. Not that everybody needs to use the same methods, but that these methods provide the same and comparable results, that data and collected for biomonitoring to interpret biomonitoring data can also be comparable from different studies. And biomonitoring takes time, and it's certainly not, it's quite expensive. It's not a cheap discipline. So I won't be able to talk about all of these challenges, but I'm just going to cover a couple of them. And one of them that I feel is very important is like the choice of the matrix and the biomarker. It's important to consider that the toxicokinetics of the chemical will be critical to inform the matrix choice. And this is an example, once again, drawn from PFASs. In this case, we analyzed about 2,000 samples, paired urine serum samples from enhanced participants for a suite of different PFASs. And considering that the detection limits were similar in urine and in blood or in serum, what we observed was that in blue at the serum data, pretty much everyone, the whole population had been exposed to some of these PFASs. However, by looking at the urine data, hardly anyone was, suggesting that, again, that the serum is the best biomonitoring matrices for PFASs, regardless of their biopersistence. We actually had to start looking at PFASs in urine because the short chain PFASs, with the idea that the long chain PFASs, all the ones on the right, had been discontinued and replaced by short chain PFASs, have a shorter half-life, and maybe urine is a better matrix. However, because the half-life of these chemicals is of the order of weeks or a month or so, still serum provides the best exposure matrix. sampling does matter, not only the matrix, but sampling does matter. And then it's very important to realize that when we, in my opinion, one sample is better than none, but still, if you have only one sample, can you characterize a person's average exposure with only that measurement? For persistent chemicals, the answer is most likely yes, because those chemicals stay in the body for a long time, so they may be able to just track your average exposure for a certain amount of time. However, for non-persistent chemicals, the answer may be very different. For chronic exposures, it may be, probably, because you may be reaching kind of a pseudo steady state, so that one sample could be a good snapshot of your average exposure. However, for episodic exposure, which are in many cases exposures, the ones that we experience every day, for example, with diet, we eat every day, but we don't eat the same thing every day. Then we have the exposure may change depending on the type, the frequency, the magnitude. So is really one sample good enough for assessing exposures? And then in these figures, and that I realize that they're very busy, but what we have here are 8 different adults, and on a log basis scale, then their concentrations of BPA in urine through a period of 1 week. And you can see concentrations are going up and down, up and down. So is one sample collecting, for example, collected here, being, the representative of something, the exposure that happened over there? At the same time, it's very important to note that when you look at the average exposure, and this is what the graph at the bottom is showing, of all the samples collected for all these different adults for a week, like the median value is incredibly similar to the median value for enhanced for adults, for about almost 1,100 adults during the same time period, suggesting that also, although there is quite a bit of variability, maybe there is not that much as is something that maybe even with this much variability, biomonitoring still can help. But it probably will require multiple collection of samples, so more than one sample. And what we are trying now is with in-person pooling. So with in-person pooling is one strategy that we have been using in more and more often with some of our collaborators, and would require is certainly biomarker dependent. For some biomarkers may be better than others, but in this example, what we did was collected a large number of samples from during pregnancy from pregnant women, and then we pooled samples, let's say samples could be pooled by day, they could be pooled by week, they could be pooled by trimester, depending on the aims of your study, and then just determining that if this pooling works, then that would save at least in cost of the analysis. You still would have to collect the samples. I mean, in this particular case, we were collecting every single sample because we were trying to demonstrate, if you want, with actual data, what the results show. But if not, then one could say perhaps collecting one sample in the morning today, another sample in the afternoon next week, and another sample in the evening the week after, and then just saying that this provides an average exposure to the next 3 weeks or so. So no matter what, there are going to be some assumptions and approximations that one needs to understand. So I hope that I showed that biomonitoring is important to inform exposure assessment for public health action and decisions, and as a result, it will impact positively public health. It can help us, just learn more about human toxicities, some exposure sources and trends and levels, and as a result, then address some evidence gaps. And at the same time, it's going to have to keep adapting to a changing world. With globalization, again, chemicals may be discontinued from production in the United States, or they may be banned from use in the United States, but maybe products that are imported from other markets where such regulations do not exist, so exposures will happen. With climate change, some chemicals that we thought, maybe we didn't have to worry that much about, or even thinking that some of the chemicals that have some pops that ended up in the ice caps in the Arctic, and then now with the melting of the ice, then these chemicals are going to be recirculating, and those could also be some new sources. And as well as, actions related to remediation and regulation that they may impact in a different way the exposures by changing exposures to existing chemicals to chemicals yet unknown. So we, at the end of the day, want to prevent disease from chemical exposure, and biomonitoring is an example of one of an interdisciplinary effort that requires collaborations from many different areas, including chemistry, exposure science, and epidemiology, and you name it. Is a process that if you want to do it well, then it requires everybody's input, and is truly, truly a team effort. And with that, I just want to thank you. I want to thank my colleagues at the National Center for Environmental Health, where I have been working for the past 23 years. The National Center for Health Statistics, these are our sister agency, CDC sister agency that conducts the ENHANCE, and my beloved collaborators with whom I have worked, some of them for the past 20 years. And also thank you all for joining the webinar. And now to you, Nicole.
Thanks, Antonia. So thank you very much for such an exciting presentation. So with that, please type your questions into the question area of the control panel. So we do have one question so far, Antonia. The question is the CDC working with Military Public Health Command on surveillance of burn pit exposures?
None that I know of. I mean, on burn sites, you said?
Burn pit, yeah, the burn pits in theater.
Burn pits. No, I mean, as far as I know, we haven't done anything, at least myself, have not worked with them. But we would be open to any type of collaboration, of course, provided that we have the tools to assess exposures of interest.
Thank you. We'll give it a minute for people to type in their questions. So while we're waiting, Antonia, I have a question for you.
Hey.
Where do you see the next type of chemical coming up that needs to have some study? What do you see?
I mean, everywhere, to tell you the truth, in everything that we do, then we're seeing, I mean, obviously, perhaps more so, or is more challenging for the chemicals that are not naturally produced, like pHs that are naturally produced, but chemicals that are man-made, that are used in products, that are added to products. So as I showed you before, in the case of phthalates, certain phthalates seem to be getting out of the market. Some phthalates are coming in, or they increased in production, and some non-phthalates are taking over too. Pesticides is also a very clear field on where changes are constantly happening. So it's hard to know exactly where to look. That's what I was trying to convey in just saying that we seem to be chasing constantly what is the next chemical that is going to be, attracting attention is really hard to do. But I think is much more likely to be in one of these man-made chemicals rather than in chemicals that are naturally being produced.
Okay, thanks. Oh, we have another question. So does the CDC have plans to couple computational modeling with biomonitoring so as to make use of the tons of valuable biomonitoring data to interpret exposure and health outcomes?
I think that we like to use the computational modeling, but more by somebody else. I don't think our expertise is in that particular area. So we would be more than happy to work with others who had that expertise, and then just we join efforts if you want. What we do best is chemistry and exposure science, and this is where I think that that we probably our efforts will remain.
Okay, thanks. And we have another question. So this one has to do with a question related to Roy Gerona's recent paper. So it's a paper on deconjugation of phenolic chemicals, and that exposures may be underestimated based on current CDC methods. Do you have any thoughts on that?
Well, I cannot speak for somebody else's method, but I can speak for ours. And I would tell you that I have no doubt that our results are accurate and precise. We have been participating in international interlaboratory studies. There are two of them that I know of. One started in 2009 or incorporated BPA in 2009, is a German program. Another one is a Canadian program incorporating BPA since 2015. We have been participating in this proficiency testing, and not only us, many other laboratories. And for what I can see, not only from our data, but from others' data, there's very good agreement in measuring the concentrations of BPA, considering that the organizers are spiking the samples with conjugated BPA, and they know the assigned values. So I, again, cannot speak for somebody else's method, but I have full confidence in ours that the concentrations that we are measuring accurately reflect exposure to BPA and have accurately reflected exposure from BPA from the very beginning.
Thanks, Antonia. So we have another question. So this one is a little long, but do you know about any biomarker or a combination of biomarkers that could actually be used to assess health risks to really characterize both exposure sources and expected health effects without using any additional data or any other additional information?
Oh, no, I wish I did, but no, I do not know. I mean, and I should say that we actually, all the biomarkers that I presented today are biomarkers of exposure. We really do not look at biomarkers of effect, but, so again, I'm not as versed in the others, but I certainly do not know of any that would do everything that the person is asking.
Okay. So a question related to the pregnant women medication and phthalates. How does NHANES obtain information about medications?
So my understanding is that a person provides a picture or the package of the medication that they take, and then for confidentiality reasons, the brand name is removed, and only the active ingredient is maintained in the NHANES database. One thing that I didn't say is that in the United States, there are two formulations of mesalamine, two commercial formulations of mesalamine. One includes dibutyl phthalate in the coating, the other one doesn't. So it's possible that, we do not know whether, like some people who may have taken mesalamine, then maybe they could have been taking the other medication at the same time because of the levels that were observed in those 6 participants. Then we believe that they were most likely taking the medication with the dibutyl on the coating.
Okay, and then there's a follow-up question to that. So do you know if they've notified the pregnant women about the elevated levels, if there are elevated levels?
I do not think so, because enhanced participants, unlike the participants in surveys in other parts of the world, they do not get their biomonitoring results except for a few of them: lead, cadmium, mercury, manganese, and selenium. Those are, to the best of my knowledge, the only biomonitoring data that enhanced participants receive. So I do not think that women would have been notified, no.
Okay, thank you. All right, last call vote. There's a question. What should be done if the HBM guidance values are exceeded?
What should be done? I mean, I guess that this is something that I would leave it for the policymakers. CDC is a non-regulatory agency. We are a science-based agency, and strive in providing the best scientific data so others can make the norms and the regulations to help us all and to protect us all. So I would leave that to to others who know much better than I do about risk assessment and regulation. That's really not what my expertise lies.
Okay. Well, it looks like one last question. Can you speak to the challenges of interpreting and communicating biomonitoring results?
Oh, I think that this is actually one of the $1 million questions. So, with the right to know, and then there's, like we always say, that the fact that you're detecting a chemical in somebody's body doesn't mean that it's going to cause a disease. Nevertheless, people tend to associate chemicals with damage. So it's, even though, as a chemist, life is chemistry, but the fact that how you need to convey to somebody that there are certain levels of a chemical in this person's body, particularly the levels are higher than expected. We all get nervous sometimes when you go to the doctor and you look at your cholesterol and it's on the borderline or on the upper side, and then you say, oh my God, what's going to happen if it's one number more or less? So I guess that is very important to just start thinking now, as we use biomonitoring more and more for different, not only for EPI studies, but also in community settings when there is some suspected contamination, that we are very clear as to what we know and what we do not know. The truth is, for many of the chemicals that we measure, we do not know whether exposures are going to result in an adverse health effect. And the other thing that we do not know is when actually exposures happen. So biomonitoring provides an integrated measure of exposure for all routes and sources. And if it is a persistent compound, the exposure may have happened years ago. It's just that now we're catching it. For a non-persistent chemical, depending on how short is the life in the body, then we can say it's a very recent exposure. But I think that we need to just be very mindful as to how we communicate results, into particularly what we know and what we do not know. Because the last thing that we want is just scaring people.
Thanks, Antonia. All right, I'd like to thank you for a wonderful webinar, and thank you all for your participation today. So just a couple of last minute items before we close the line. So within the next day, participants will receive an email that includes a link to the evaluation. So please take a moment to provide your feedback. We're always interested in how we can improve. The recording of today's webinar, along with the slides, will be posted on the ISCS members only portion of the website. And then I'd like to announce that next month, on February 19th, we will have our next webinar on perspectives on science communication, social media for scientists, with Dr. Pallavi Pant, who is at the Health Effects Institute, and she's also the social media editor for the Journal of Exposure Science and Environmental Epidemiology. So we're very much looking forward to her talk on social media. And a last reminder, we are currently accepting both symposium and pre-conference proposals for the annual meeting, which will be taking place in Oakland, California in September. So please visit the ISES2020ca.org website for more information. And with that, I thank you all for participating today.